Okay, what I want to do in this video is start to bring together what we've learned in the past playlist about acids and bases and pH. And specifically what I want to focus on is a class of reactions that are called neutralization reactions. Neutralization reactions. All right, now the definition of a neutralization reaction is the following. So this is the reaction, and I'm going to abbreviate reaction as RXN. So it's going to be the reaction between an acid and a base that produces water and a salt. All right, so a neutralization reaction is a reaction that happens between an acid and a base that produces water and a salt. This is a very important class of reactions because in chemistry we use neutralization reactions to quantitate things. So what I want to do is take you through the basics of this, and then there will be another set of videos to deal with how we use these reactions actually in the laboratory. So to start the discussion, what we're going to do is we're going to focus on what I consider to possibly be the most classic neutralization that there is, and that's the reaction between hydrochloric acid and sodium hydroxide. Now, this is a very special neutralization because it's the reaction between a strong acid and a strong base. The major products are going to be, as I stated in the definition, water and a neutral salt. A neutral salt. So, and I'm going to label this to be really clear about it. So we have a strong acid and a strong base. Now, in previous videos, I laid out the groundwork for strong acids and strong bases. So in general chemistry, most likely you will be confronted with what I call the 6 strong acids, and there are 5 strong bases, and so that's what I want to focus on here. And the type of neutralization reaction, therefore, that we're going to focus on is going to be the one between a strong acid and a strong base. What the viewer needs to realize is that there are other types of neutralization reactions, and most of them are going to form, many of them are going to form water as one of the main products, but there are other kinds of neutralizations whose products won't be the same as what I'm illustrating here, although they all produce some kind of a salt. So let's take a closer look at this particular neutralization. The first thing that I want to point out is why the term neutralization is being used in the first place. So let's look at the coefficients of this reaction. All right, you can see that there's a 1 in front of the HCl and in front of the NaOH, in front of the H2O, and in front of the salt itself. So if I was to provide 1 mole of hydrochloric acid in a reaction with 1 mole of NaOH, and this reaction was to go to completion, which it does, and that's something that I want to point out to the viewer. This reaction is what we call stoichiometric. All right, if there is an equilibrium to this reaction, it lies so far to the right that when you combine hydrochloric acid and NaOH in the same reaction container, the reaction is immediate and it goes to completion. So the point is that if I provide equal molar amounts, so 1 equal molar, meaning the same amount of material in both cases. So in this example, we're using 1 mole of hydrochloric acid with 1 mole of NaOH. We can set up a little table. We can call this situation here the before the reaction, which means there will be 0 of this produced at that point and 0 of this. After the reaction is over, there will be 0 of the hydrochloric acid and 0 of the NaOH, and we will have produced 1 mole of water and 1 mole of the salt. So in the reaction mixture, once the reaction has gone to completion, all we're going to have is H2O and NaCl. Now, we call NaCl a neutral salt. And what that means, the reason we call it a neutral salt is because the sodium chloride has no effect on pH of the reaction mixture. All right, so it has no effect on the acidity, and maybe I'll add that here. So no effect on acidity. And this is going to be true for any of the strong acid, strong base neutralizations between any of the strong acids, the 6 strong acids and the 5 strong bases. They all produce neutral salts. The salts have no effect on pH, no effect on acidity. Now, let's look at the other product of the reaction. In this case, we've produced water. And I've talked about the fact that water itself undergoes this unique reaction called autoionization, where it can self-ionize into H3O plus and OH minus. And we learned that in pure water, the concentration of H3O plus is equal to 1 times 10 to the minus 7th. And the base is also equal, the base is also equal to the same concentration. So the main point is that the pH of water is equal to 7. So the pH is equal to 7. So the unique feature of a strong acid, strong base titration is that the pH of the reaction mixture is going to be 7 after the reaction is over. And the fact that there's a salt present in the reaction mixture has no bearing, because when you react a strong acid with a strong base, the salt that is produced is a neutral salt, and like I said earlier, has no effect on the acidity. The only product in the reaction mixture that has any effect on pH is water, and the pH of water is 7. So these reactions, I believe, were called neutralizations in the first place because the major product that you get out of the reaction that has an effect on pH is water, and the pH of water is 7. Now, the other thing that I want to do here is talk about the net ionic equation that's associated with this. So notice that we've got, in terms of the strong acid, it's aqueous, and it's being combined with an aqueous solution of NaOH. It's a strong acid, which means it's fully ionized in water. It's being mixed with a strong base, which is fully ionized in water. And the outcome after the reaction is over is a neutral salt, which is fully ionized in water. So we can rewrite this equation this way. Now, the H2O we don't separate. All right, we keep that together because it's not fully ionized, right? Coming back to this thing here, there's very little of it actually ionized in solution. However, the sodium chloride is fully ionized, so we need to write it this way. Now, when you look closely at both sides of the reaction, you can see that we have sodiums and chlorides as spectator ions, so we can cancel these out. And lo and behold, what you see is that the net ionic equation is the formation of water. And this net ionic equation represents the net ionic equation for the neutralization of any strong acid with any strong base. And with that, what I'm going to do is go ahead and close this video.